Yes guys, today we're going to be going through the binomial theorem. So let's start off by letting a and b be real numbers and n let n be a natural number. So that is natural n. So what the binomial theorem states is that when we have a plus b to the power n, we can write this as a sum. So this sum is from r equals 0 to n choose r, a to the n minus r multiplied by b to the n. So we're summing from, as the term r goes from 0 up to n, and each term will have n choose r, a to the n minus r, and b to the n. So this leads us on to a question which is, what is n choose r? Well, n choose r, we can say it's the number of ways to choose r objects from a total of n objects. And one important thing to know is that when you're choosing r objects from n, the order we choose them from does not matter. We're just selecting, if that makes sense, not arranging. So n choose r can be written as a formula, which is n factorial over r factorial multiplied by n minus r factorial. So now we need to show where this formula actually comes from. So we start off with n factorial, and this n factorial here counts the number of ways to arrange the total amount of objects, so in this case n. But the thing is, right, we're not arranging all n, we're just arranging r object. So first we imagine that we don't care about the order at all. So the number of ways to choose r objects from n would be n factorial divided by n minus r factorial. The reasons this works is, well, because we start with n factorial arrangements, but we divide by n minus r factorial to ignore the leftover objects that we didn't choose. Now we need to show why we divide further by r factorial. So let's say we have an order. So, we do care about the order. And why is this important? Well, if we're choosing from A, B, C, and D, and we want to choose AB, well, choosing A then B is the same as choosing B then A. So if we see these as two different choosings, then we are overcounting. So the way we get rid of this is, well, we divide by r factorial. So we have n factorial divided by n minus r factorial, further divided by r factorial. And what this gives us is the number of ways to choose r objects from n without caring about the order. And the r factorial, of course, removes the overcounting. And then the next bit we should cover is, why does this actually appear in the binomial expansion? Well, let's say we're expanding a plus b to the n. So we have a plus b times a plus b times a plus b n times. To form each term in the expansion, we are either choosing from every bracket either an a or we choose a b. to get a term like a to the, for example, n minus r times b to the r, we must choose b r times and then a n minus r times. So the number of ways which r brackets give us b is exactly n choose r. So this becomes the coefficient of that term you're looking for. So that's about it. The binomial expansion comes from multiplying out these n brackets, and each term is formed by choosing either an a or choosing both a and b. And what the coefficient does, it counts how many ways each term can be formed. So that's why n choose r actually comes about in the binomial expansion. So to conclude, the binomial theorem isn't just really a formula, it's more a counting argument. And that's about it for today. Hope you understood that, and goodbye.